So now we're going to have a look at the addition rule. So when we're working out with set notation, our addition rule looks like this, which means that the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. If we think back to when we just had a look at Venn diagrams, if we had our Venn diagram where we have a circle for A and a circle for B, the reason why this rule works is because if we colour in our circle for A and then if we colour in our circle for B, we can see that we are counting this middle section twice. So if we're wanting to find the probability of A or B, we want to add the probability of A and the probability of B together and then subtract the middle bit so that then we're only counting it once. So we're going to look at some examples of how we use this. So given that the probability of A is 0.35 and the probability of B is 0.45 and the probability of A and B is 0.13, find the probability of A or B. So that means the probability, so I'll use a dark coloured pen, the probability of A or B is going to be our 0.35 plus 0.45 minus 0.13, which gives us 0.35 plus 0.45 minus 0.13, which gives us 0.67. Next, we are given the probability of A, and we're given the probability of B, and we're given the probability of A or B, and we're trying to find the probability of not A or B. So for this one, we're going to have to start off by finding the probability of A and B, because if I quickly sketch a Venn diagram, and if this is my circle for A and this is my circle for B, I don't know how much of my 0.6 goes in this section for A, and I don't know how much of this section of my 0.7 goes in this section for B, meaning that I need to find A and B first to find out what's left over to go in the end pieces. So if we write down our addition rule, probability of A or B equals probability of A plus probability of B minus probability of A and B. Sorry, I've gone over a little bit into the next box. That means that we know that 0.9 equals 0.6 plus 0.7 minus whatever our probability of A and B is. So we can put this into our calculator. You could rearrange it, but if you wanted to, you could go into equation, solver, and we can just type it straight into here. So 0.9, shifting in the decimal point for our equal sign, 0.6 plus 0.7 minus, and then for our A and B bit, that's our unknown, we're going to use this X theta T button. Remember that you have to click XE twice to get our answer up, which gives us the probability of A and B being 0.4. So that means that now we know that we're going to have 0.4 in our A and B section. And because the probability of A is 0.6, that leaves 0.2 for this section here. And because we know that this circle here is going to add up to 0.7, that leaves us 0.3 here. And just as we did when we looked at Venn diagrams earlier on, we're going to have a probability outside of those two circles that's still inside our rectangle. So far we have 0.2, 0.3 and 0.4, which adds up to 0.9, which means we're going to have 0.1 outside. So now I'm going to change to my highlighters. I'm looking at not A. So if you remember from before, that means everything that's not in the circle for A. also looking at B. So that's everything inside the circle for B. And because it's or, I want where it's yellow and blue and orange. So I'm wanting all three of those sections. So that's 0.4, add 0.3, add 0.1, which gives us the probability of not A or B being 0.8. Take the opportunity now to pause the video and give the Now You Try a go. So hopefully you've paused the video and you've tried the Now You Tries. So again, for the probability of A or B, we would be starting off with 0.4 plus 0.6 minus the probability of A and B, which we're trying to find. Now we actually already know the probability of A or B. That's going to be 0.9. And again, we can put that into solver. You could just rearrange it if you wanted to. Put 0.9, shift and then the decimal point for our equal sign. 0.4 plus 0.6 minus, and remember that you use the x theta t button to find the probability of A or B. A and B, sorry. Let me just go over my and sign, it's got a bit. There we go. Which gives us the probability of A and B being 0.1. Remember, you have to click execute twice, otherwise it'll still have our 0.4 in from this question here. For the second question, again, we're going to have to work out A and B, and then we're going to have to draw our Venn diagram. So the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. We know the probability of A or B is 0.62, the probability of A is 0.3, and the probability of B is 0.45. So again, we can type this into our solver. 0.62 equals, shift and then the decimal point, 0.3 plus 0.45 minus, and then we can use our x theta t button to find for our probability of A and B. Execute, execute, there we go, and the probability of A and B is 0.13. So we can draw our Venn diagram. That circle can represent A, this circle can represent B. We know that we're going to have 0.13 in the overlap of our circles because that's the probability of A and B. Left over in the probability of A, well, we know that A is going to add up to 0.3, which leaves us with 0.17 for this section of the circle. And we know that B is going to add up to 0.45, which leaves us with 0.32 for this section here. And again, altogether, it should add up to give us 1. So we can use that fact to help us to find the value that should be outside the circle here. So that's 0.17 plus 0.13 plus 0.32, which gives us 0.62, which means that we're left over with 0.38. And we can double check that because we knew the probability of A or B was 0.62, and that makes sense then that not A or B is going to be 0.38. So now we're looking at not A and not B. So if I change over to my highlighters again, not A is going to be everything outside of my A circle. Not B is going to be everything outside of my B circle. And because this time we're looking at and, I only want to count my green part, the part that's gone green, because the 0.17 is only yellow and the 0.32 is only blue, I only want to count my 0.38. So the probability of not A and not B is going to be 0.38. Unfortunately, the addition rule is not given to you in the formula book. Neither is the formula for conditional probability. So conditional probability, also sometimes called the multiplication rule, looks like this. Now, we have talked about conditional probability before, but we haven't talked about it in terms of an actual formula. This works out well if you're not having to draw a Venn diagram to start off with or a two-way table. So we're going to work through the examples. So we have the probability that a randomly selected person is left-handed is 0.16. The probability of them being blue-eyed and left-handed is 0.05. Given that someone is left-handed, so that's going to be the probability given that they're left-handed, find the probability that they have blue eyes. So given that they're left-handed, the probability that they have blue eyes. Using the notation at the top, we're going to have the probability of blue-eyed and left-handed over the probability that they are left-handed, which is going to be 0.05 divided by 0.16. So 0.05 divided by 0.16, which gives us 0.3125. The next now you try question is in an exam. 2 reasoning problems, 1 and 2, are asked. 35% of students solved problem 1 and 15% of pupils solved both the problems. How many students who solved the first problem also solved the second problem? So that means that we're looking at the probability that they solved 1 and 2 given that they solved problem 1. So on the top, we're going to have the probability of solving 1 and 2 over the probability that they solved problem 1. Now, solving 1 and 2 is solving both the problems. So on the top, we're going to have 0.15, and on the bottom, the probability that they solved problem 1 is our 0.35, which gives us 0.15 divided by 0.35, which gives us 0.429 to 3 significant figures. I'm going to give you a moment now to pause the video and try the Now You Try questions. So the first Now You Try question, we've got the probability that a randomly selected adult is female is 0.52. The probability that the person is both female and earns over £20,000 per year is 0.32. Find the probability that a woman earns more than £20,000 per year. Now, it's not as clear this time what we're looking at because it doesn't say the words given that. But it does say the probability that a woman, which means that we're actually looking at, given that this person is a woman, that they earn over £20,000 a year. So on the top, we'll have the probability that they are a woman and they earn over £20,000 a year. And on the bottom, we're going to have just the probability that they are a woman, which gives us 0.32 over 0.52. So 0.32 divided by 0.52, which gives us 0.615 to 3 significant figures again. Next, we're looking at, in a group of 100 sports car buyers, 40 bought the alarm system, 30 purchased bucket seats, and 20 purchased an alarm system and a bucket seat. So this time we've got more information, so we need to be careful at what we're talking about. If a car buyer chosen at random bought an alarm system, so that's our given that. So given that they're buying an alarm system, what is the probability that they also bought bucket seats? So here we're looking for bucket seats. So we're looking at the probability of A and B over the probability of A. So alarm and bucket seats, 20 purchased an alarm and bucket seats, so that's our 20 out of 100. Remember, we're talking about probabilities here. Out of the probability that they bought an alarm system, which was 40 out of 100. And when we put that into our calculator, we should get a half. And remember that the formula for the conditional probability and the formula for the addition rule are not given in the formula booklet, so you have to try and remember them. Thank you for listening, and next time we're going to go over independent events and mutually exclusive events.